Hubhopper Originals.
To start your podcast for free, log on to studio.hubhopper.com.
Hello, everyone, and welcome back to Indian Genes. We have a superstar with us today who is an international space lawyer. Also, currently, she is the community manager at the European Space Observatory and a lecturer of public international law at Universidad de los Andes in Chile. She has also been a guest lecturer in workshops like Yes to Space, and someone who has a very, very interesting story to tell us. So, for anyone who's interested in space, space law, the future of space, this is going to be an absolutely exciting episode. So, Indian Genes is very proud to present to you our exciting conversation with none other than Isi Casas Del Valle. So, Isi, from everyone here in India and Indian Genes, an absolute pleasure to have you. A very big and very warm welcome to you. We have been communicating before, but it's nice to have you on this podcast, Isi.
Thank you so much for inviting me. It's a great pleasure, and I'm always happy to talk to you again, Joaquin.
Great. And for a lot of our listeners here, Isi, I think this is going to be a very interesting episode because by just looking at what you've been doing or what you have been involved in, you seem to be a very high achiever. But let me just leave that to you. And if you could give us a little bit of a background, you're speaking to us from Chile at the moment, I know that. But if you can tell us a little more about the person behind Isi and how you got into whatever you are doing now, that would be very interesting.
Thank you, Joaquin. Yes, exactly. I'm actually born and raised Chilean, so I've always lived my whole life here. And now I'm going to move to Dubai, which is going to be my first big move. I'm very excited. But I've always lived here, and I've always been a true believer that countries like Chile and even India and many countries can actually make it in the space sector. So when you ask me, like, how did I get here? It was a very long journey with ups and downs. I mean, it was not a straight line at all. As I was telling you, I'm Chilean. I'm a space lawyer, but now I'm working in communications in the European Southern Observatory, ESO, which they do ground-based astronomy, and their telescopes, which is a very large telescope, ALMA, and La Silla, and also they're constructing the extremely large telescope, the ELT. That's where I'm working at the moment, but it's been quite a ride.
We definitely want to come to what you have been doing with the European Southern Observatory. But before we get there, it's very interesting when you speak about space law, and that is, I guess, what you primarily set out to do. Now, I think a lot of us are quite familiar with law as far as terrestrial law is concerned. But when it comes to space law, uh, I'm just trying to figure out are we setting boundaries or there is a legislature, there are rules and regulations. And so I'm just trying to get a little bit of a hold on when you talk about space law, where do you start?
So there is a saying that wherever human goes, the the tax authorities also follow.
Mhm.
And that applies the same into law. Whichever activity that we develop as human beings, eventually the law follows. And that is a very special scenario because since although we are very creative species as human beings, we can't anticipate everything that we're doing. So the way it works is that technology and the space sectors continues to develop, to grow, and as those activities progresses and develops, then we go behind it, regulating it. So when you study law society, everybody's super familiar with family law, criminal law, corporate. But in space, it was all born when Sputnik 1 was launched. I mean, that day, the USSR, when they launched this first object through the 100 kilometers, through the Kármán line into space, it was revolutionary. And that was the moment that space law was born. Because for the first time, a state had launched something into space but also they didn't have any claims of domain or sovereignty or any other of these ideas to own something in space. So from that activity, and later we had Yuri Gagarin, which was the first man to go outside of the planet, Shepard from the US. I mean, we've had a lot of things happening in space. Is that as human beings, we saw the potentials, but also the dangers behind this. So we came across this, the first and the traditional golden era of space law, which would be where we have our international treaties. So we do have international treaties that regulate the space activities, and the Outer Space Treaty would be our Carta Magna, would be our constitution for space. And from there, we moved forward into other areas of international space law. But we do have laws, we do have treaties, and we even have like this kind of constitution.
And does the United Nations General Assembly or their resolutions have anything to do with it? Because I think independent nation states have their own legislation and governments regulated space activity. How does space law tie into both these bodies?
So exactly, the United Nations has a very important mention, and within the United Nations, you know that they have different offices, and the UN has an office for outer space affairs, and that is the UNOSA, as it's called, and it's an office of the United Nations Secretary that promotes and facilitates the peaceful cooperation, the peaceful uses of outer space. So the United Nations has this UNOSA, and then UNOSA is the one that is responsible as well, that where they have the COPUOS, which are the committees of peaceful uses of outer space as well. And there's a legal committee and a technical scientific committee. And when all the member states they participate from this, and other organizations that have a voice but not a vote, like the Space Generation Advisory Council (SGAC), they get together in Copuos these sessions, and they come with recommendations. There's negotiations and anything that has to be discussed and developed to further space activities under a space law. And all of this is under the umbrella of this United Nations Office of Outer Space Affairs, which is located in Vienna, as the UN is also there.
Right. And considering what we currently see happening right here on Earth with the environment or with global warming, we have two groups of people. There are disputes. Now, do you see this as an advantage that we are very early into space law? So, setting down, I'm sure you have certain principles that you would have set down, and I mean, the team would have set up with. So, for example, you're talking about damages or space objects or space debris. Is it better that these particular regulations or laws can be laid down early? And I think I don't even know if it's early as far as space debris is concerned. But do you see this as both a positive, that it's at this time that we're doing it? Because as we move into this space race or the next space generation, it's going to get more complicated and it could be late then.
Absolutely. As a personal opinion, I think it's always good to regulate, and to regulate in a positive sense. So, all international treaties, even contracts, they are made to be executed, right? That is like the whole point. So, when we are regulating activities, we are setting the fundamental pillars that are going to legislate our space activities. Now, we do have those basic pillars in the international treaties, but these treaties are pretty old. The last one, which was the Moon Agreement, is from the beginning of the 80s. So it's been a while since we have these international treaties. And some people, including me, wonder if international treaties are still the way to go to govern over space activities, but that there are other things that could happen now, and that maybe they're a better solution. As you said, we are the new space generation, and we're not the Apollo generation, we are the Artemis generation. And within Artemis, you have Artemis Accords, for example, that are these bilateral agreements. But those also have their problem, because the Artemis agreements, they have a very Western view that comes from the United States. And even though the space activities and space is so fascinating and it's so inspiring, but there's also a little bit of, not a little bit, actually, a lot of politics behind it. So
Mm,
we are a world that is divided. So the eastern side, especially Russia and China, have other views, maybe. So they could have their own Artemis Accords, which could be very different from what the United States and the Western world is seeing. So more than positions of if we should legislate now or should legislate later, is about the common interests. You have to bring together the interests, and I think the interest is to protect the environment, to protect Earth, to protect us, and use space to our advantage and to our benefit because it has so much to offer. And honestly, the best spaceship ever built is Earth. So we have to protect it. And now is the moment to be sustainable. You said space debris is a problem because it was never regulated before. And I'm a true believer that this Artemis generation is way more knowledgeable and conscious on space sustainability. So I think now is the moment to regulate for the future generations that will be interplanetary species and will live in space. But now is the moment to protect them and to give them a good Earth and to give them also a good space environment. So I think now is the moment to regulate in pro of the future generations and showing how the Artemis generation can do things differently, sustainably, and bring all this interest together to further in space for Earth.
right. And I agree with everything you say because I think it was the Chicago Convention in 1944, I guess, when all this did get formalized. But what I've always been thinking about was with uh, terrestrial disputes, where we have disputes with boundaries and national borders. When we talk about space, the fundamentals and principles are totally different, right? Because everybody is collaborating today at this very early stage. So whether you just spoke about USSR, or rather at that time it was USSR, but I think a great example is you sitting in Chile and looking after what you're doing with the European telescopes, and this is collaborative across the globe. Whether it's results, and I think we'll come to a little bit of results later. So during this time, how easy or how difficult is it for somebody to set boundaries as to who becomes the final authority as far as experiments or people deciding to send up satellites at different levels in space? I'm still wondering about that.
So, as you said, space is all about collaboration. And that is a very interesting and a very amazing way to describe the space industry because the space industry is at its heart international, intercultural, interdisciplinary. It's one of the best symbolisms that when humans come together, we can build and we can make great things. When I see the European Southern Observatory and I see the telescopes and the observatories that they build, they are these gigantic things that can do incredible things like observe the black hole at the center of our galaxy, Sagittarius A. That is incredible. So when we come together, we can do amazing things. Like since the 2nd of November of the year 2000, as a human species, we've never, again, ever in history, lived all together on Earth. Actually, since that day, there's always been someone in the International Space Station. So when we come together as collaboration, we can do the unimaginable things, like never again in history to be a species that we're all together on Earth. And that is an amazing thought. Or we populated another planet like Mars with robots. Mars is completely populated by robots, and that was us. So there's so much greatness in us, but that's why we have to move forward in a way that we can work peacefully in space, because space is hostile. We're not made to live in space. I mean, the radiation, the amount of like space debris that is ours or that is natural, and the amount of like the temperatures, the low temperatures, the high temperatures of the sun, like everything wants to kill you in space. So We must learn to work together in order to survive because this hostile environment is working against us. But we have proven that if we work together, we still manage to do that, like the International Space Station now, or the moon base that's going to be coming in the next years. So no one is owner of everything, and that is what the this constitution that I was saying, which is the Outer Space Treaty, said from the very beginning in their articles, in Article 2 specifically, where they're saying that no one owns any celestial body, no one owns anything in space. So, because it belongs to whole humanity. So, as we have an Earth, we had ways to acquire domain, and that could be through occupation, that it means that if it's from no one, which is called in Latin res nullius, so if no one owns something or it seems to be abandoned by its owner to be taken by other person, which are the res derelictae, then I can just go there and occupy it and make it mine, which is what Europe did back in the day with many of its colonies, especially from South America. They just went there and they just made it their own. Or accession, which means that if something is close to me and then I can access it to my body. So there's many ways to be owner of something, and that was immediately forbidden in space. We saw, and I think for one of the first times we looked at history, we looked back and we learned from our mistakes to do that. So this was the base and the center to say the pillar that no one can own anything in space, and there's free access to the use of space. And that means that the exploration, scientific uses of space is accessible to anyone. Now, that is a little bit on the theory because anyone has access to space, but technically and financially, that doesn't mean that everyone can go to space, you know?
Right.
So there's a difference there. But in principle, anyone can go to space. No one can own anything in space, like a planet, a meteorite, like the moon. No one can own it, and we all have the freedom to go there and to further space explorations and scientific research. Now, when it comes to space mining, for example, and to other areas, that is not properly regulated. And many people have their doubts on how we should approach it. If it's an approach more on the moon agreement and say that it belongs to the whole humanity, so basically we can't do much, or an approach like the Antarctica Treaty, or an approach like the high seas and the fish, that no one owns the high seas, but I own the fish there if I fish them. So then I own the resources, but not the places. So I could go to a meteorite, not own it, but take the lithium or whatever I need and use it. So there's still a lot of questions more than answers, but that's why it's so exciting to be a space lawyer now because we're setting the basics for everything. So it's incredibly exciting. But basically, as a summary, no one can own anything. There's no agreement yet on space resources, but space is accessible to anyone who wants to use it for exploration and scientific research.
Right. And you did speak about the Moon Treaty, which basically, I guess, was an agreement for governing of activities uh, on the moon and other celestial bodies. You also touched upon the moon base that would be coming up soon. Is there something you can briefly summarize? What exactly is that uh, all about as far as the moon base is concerned?
Yes. So from you mentioned, I did mention the Moon Treaty, and the Moon Treaty is this agreement that governs activities of states on the moon and other celestial bodies. So it's precisely what you said. It's not only the moon, but it's open to other places. But the thing is that this multilateral treaty actually it's very complicated because when you look at the outer space treaty, most countries in the world have signed it. So and there are state parties. So they are under the like they are binded by this treaty. When it comes to international law, you can be binded by a treaty, but that does not make it enforceable. You can't enforce it or force it for someone to comply to obey the treaty, like we do in civil law or in more national laws, because there is nothing superior to a state. So you can't send a state to jail. So international law works in a very different way. Now, the Moon Treaty, it was signed by 11 people, like countries. So, and if you've ratified it and you are a state party to that, you will be blinded by the Moon Treaty, but nor the United States, China, Russia, nor India also didn't ratify this agreement. So, many countries in the European Union or Israel, Japan. So, I'm mentioning the big actors in space. None of them signed it or ratified this agreement. If you sign an agreement, a treaty, it means that you won't go against the treaty or make it difficult for people to proceed with the treaty. If you ratified it, it means you're binded by it and it acts as a national law. That's the difference. But none of the big actors were part of it. So it leaves the question that everyone who's part of a big actor in space is not part of this treaty and everyone else is. These states are actually not mandated by what this Moon Treaty says. So in practical terms, it can turn out to be a pretty useless treaty if the United States is the one that's going to the moon.
Mm.
And now, so that's like the first part. So the Moon Treaty has nothing basically on the moon base for the United States. Although the Moon Treaty did repeat a lot of the principles of the Outer Space Treaty, so it's not that bad. But what makes it different, like everything has to be to the benefit of humanity, that changes a little bit. So
Mm.
I don't know if your question if the question was answered.
No, it was. I just wanted a little bit of background on the Moon Treaty because that's what I thought. It was a treaty, but how effective it was. And I think also you had mentioned the moment a commercial aspect gets into any exploration. So if we are talking about space and we're talking about moving into space, but now we do know that you can harvest minerals from or exotic minerals from an asteroid, for example. And I think that initial stages of getting into that kind of a project are already on. And then the second part about it is we continue doing what we're doing here, which is defense, and we talk about militarization of space. Now that makes it even more complicated because when we talk about defined boundaries on earth, it's easier to control because you know who's crossing what boundary. But the very fact that space doesn't have a boundary and it belongs to everyone, then you can set up your military defense systems in any location that suits you, and there's nobody to send you back.
So one of the principles in the Outer Space Treaty, and this is the constitution, so to say, of space, does have one of its articles and basic pillars is the non-militarization of space. So you basically what it says is that you can't have nuclear weapons or you can't have anything that is military as an offense in space. And defense, it's a very thin line because, of course, if I have, for example, a laser that's going to shoot to bring down satellites, there's a very fine line between a solution to space debris through using a laser and basically a laser weapon or a Death Star. So there's a very fine line which is between defense and what will be like militarization of space. So when it comes to the military part, and I must say that it's not my area of expertise, I'm more into like policy or even commercial parts of it. When it comes to militarization, the fundamental thing is that, as you say, if you have a military base anywhere, in principle, you can have a moon base or any base that you want anywhere in the solar system and in the universe, because when the international treaties talks about space, it's just general space, but it cannot have any sorts of weapons or things. Now, I do think that that is a little bit tricky when we will begin with space resources, as you said, because if I go to space and, okay, this asteroid is not mine, but I'm taking the resources out of it to make it my own, like the Luxembourg national policies allow you or the United States, and then I want to defend it from people who want to steal it, for example. How can I do this if there's no militarization in space? But should we be at that point? So there's a lot of still questions going around this and the potentials of that. When President Donald Trump said that he wanted to put boots on the moon and have this space force, it should be more focused on being a peacekeeper like the United Nations is, and not peacemakers, which is a very different thing. So we should be able to have military, for example, defense, but it shouldn't have any massive destruction weapons or nuclear weapons or anything that could be potentially dangerous, because we're always under this paradigm that is the peaceful uses of outer space. And you should be a peacekeeper, as the United Nations is, and not a peacemaker, which is very different.
That's interesting. And when does technically when we talk about space, is it when does it actually start? Is it 50 kilometers or 60 kilometers? Do we have a definition of when we actually say, okay, we are now talking about space because there is no boundary?
There is no agreement on this, but the most accepted theory, and that some countries do recognize it, like for example, I think Australia recognizes it, and other countries as well, is Denmark. I think lately as well also recognized, and it's called the Kármán line. So the Kármán line is basically this part of the atmosphere that if you go from sea level upwards between the 80 and 100 kilometers, so basically everyone says 100 kilometers to be sure, is where outer space would begin. But the scientific explanation of this is not a random number that lawyers picked, like 100 kilometers, because it's a nice round number. It has a scientific purpose, and that is that when you are in within air, then all these air objects, which are airplanes, because we have space objects as well, which are like a satellite, for example. But an airplane is airworthy, so it can actually fly in the air as long as it is sustained. But there's a phenomenon that, depending on how thick is the atmosphere, at 80 kilometers or 100 kilometers from the sea level measured up into space, then you lose sustentation. So the airplane would not be able to fly anymore. So it's not airworthy and it would fall. And that is where we consider is that space begins, because that's where the air realm would be closed and the outer space would begin. So that is where it begins. So it's basically, as easy to remember, is 100 kilometers from sea level, and that would be the Kármán line.
And we were talking about collaboration earlier between nations. On the other end, we would also have individual nations that want to set up on missions of their own, or everyone could have different scientific objectives for their particular missions. And now, to add to it, we also have the private sector that is becoming, I think, very active as far as space exploration is concerned. And I see that as that jumping further than what governments would actually do. And even if you take NASA, for example, the private sector like SpaceX is is more active. Now, does that complicate things for you as a space lawyer, or when you're thinking about it? Because you've got, let's say, if you're writing law for 190 countries, but now that you have within every country private organizations that can then move into space, how is that something that you also think of as far as space law is concerned? Is something that's on the table?
It's definitely on the table because there's different eras in space law, like in the history of space law. And effectively, at the beginning, it was only in the first two stages. It was considered that it was an activity conducted by governments because space has tremendous benefits, but it's also a very expensive industry. And so it was always thought that in the 60s and even 70s and 80s that it was obvious that only governments would have that ability and the budget to conduct space activities. So all the international treaties are understanding that we're dealing with states. But they did get a little bit closer to the idea to have eventually organizations or even a private sector to be involved. So they did have a vision of this, but it was not fully regulated. And today we're at the moment that Jeff Bezos, who is the owner of Blue Origin and Amazon and many other things, Jeff Bezos has more money that some countries have in their GDP. It's insanity. So we are at a point that SpaceX, Blue Origins, and even Virgin Galactic, they're developing in a faster way with more risks than they were taking during the Apollo missions. The slogan was that we can't, like, failing is not an option. Whereas in the Elon Musk literally said failing is an option. So there are more risky organizations that are a little bit more risk adverse. So we are going into another era where one could think that is unregulated, but the reality of is that there is a liability convention, and it is also part of the outer space treaty, like this constitution, where it specifically says that governments are responsible, so they're liable for the activities conducted by the private institutions, by their nationals, by NGOs. So eventually, if there's a dispute or a problem, or Starlink, for example, has a problem in outer space, then the United States would be liable for this. Once the United States would then deal with Elon Musk in their own laws, that's on them. But at an international level, the states are responsible for this. And not only where the company is constituted, but also, for example, a launching state. So if Russia has a problem while launching their Soyuz and their rockets, and they launch it from Kazakhstan, then Kazakhstan, as a launching state, and Russia both would be liable for a problem that happened during the launch. And there is two kinds of responsibilities or liabilities. One is with from space, so from the Kármán line, this 100 kilometers out to space, and below. So all the activities that are below this line, and it comes from Earth, even if you're on Earth, even if you're launching, during the launch, in air, whatever happens, you are completely liable for whatever happens. And that is the objective liability. So, for instance, if you have a dog and the dog misbehaves and bites someone, you would have to start to see if you're liable or not, if it was the dog's fault or not. Mike Tyson has a tiger as a pet. If you have a
Mhm.
tiger as a pet, you're liable for whatever the tiger does because you have a wild animal as a pet. That is objective responsibility. So when you are within Earth, so not in outer space, you are Mike Tyson with their tiger. You're completely responsible for whatever happens, even if it's your fault or not. Now, when you're in space, that is like you owning a dog. Then you have to prove that you've been negligent, that you acted with dolos, that with dolo, or like you intended to do damage, or you were super negligent in what you were doing. But if you were not negligent, it was an accident and it was not your fault and it was out of your control, unforeseeable circumstances, force majeure, put it in the name that you want, then you're not necessarily responsible because space is dangerous, space is unpredictable, quote unquote, and
Yeah.
it's hostile. So responsibility and liability works differently on Earth with space activities and space activities in space. And also, in any event, the states are responsible, and not only the state where the company is, but any state that is involved in the process. And then their own states have to deal with their privates. So, no, like it's not like Elon Musk or Jeff Bezos or Richard Branson are just in the Wild West. It could
Mm.
seem like that, but eventually, when they start to have problems, because they will have problems in the future, we are more actors now. I mean, chances are we're going to run into each other. Is that then their states are going to be internationally responsible for their national and private activities, which is very special and fascinating. So it's not too much the Wild West.
As we look at the amount of missions planned in the future as well, you've probably been ahead of the curve as far as talking about what if something does go wrong, because things do tend to go wrong. And I was going through a paper that you had published called Disaster Management: Space Based Solutions for Developing Nations. And I think there you covered the aspects of disaster management in space. And I think that's very important that somebody talks about a framework for when things go wrong, because it's all good that we're moving in one direction. But I think that has to be balanced. And would you want to give us a little bit of oversight on that specific paper that you published?
That paper was a result of a collaboration of the International Space University, and it was a very interesting paper. We had a lot of nationalities and people involved. But the idea of that paper was to use position navigation and timings, or PNT technology, to help with disasters, but on Earth. So if you have an earthquake or a tsunami, how can we use space activities and observation, Internet of Things, and all difference of technology in observations and PNT to help us manage the different cycles in the disaster management like cycle. So any of the stages like recovery or stages as mitigation, for example. So it was most understood for how space can be beneficial for Earth, especially for countries that are in the circle of fire, which is where basically everything around the Pacific Ocean, because we have so many earthquakes and so many natural disasters. So it's more understood for that part. So more than disasters in space, it was meant to further understand how space technology can help us mitigate and can help us recover from natural disasters.
Right. And also, speaking about these particular missions, now that we have nanotechnology as far as satellites are concerned, earlier it used to be the bigger satellites, but do you see a big shift towards nanotechnology satellites, and what is your take on where this particular space is going?
Yes, they're definitely growing in this direction. And it's because cube satellites, nanosatellites, microsatellites, and all these tiny. The other day I saw a satellite that literally was like, it fit in the palm of my hand. I mean, it was tiny. And yes, they can be very contaminated. And because space debris, especially micro debris, is very dangerous. But on the one hand, we do not have a definition of what is space debris or what could be considered. And on the other hand, the size of these satellites are a double-edged sword because on the one hand, they are in LEO, so to deorbit them or they just fall into the atmosphere and burn, so they're very easy to avoid them have as space debris, especially when the objects or they're not working anymore. But they do have this problem that because they've been developed with a certain type of technology and based on positions and not common interests, many of them do not have the technology, or many companies have not invested yet in having satellites that protect and they are in accord with dark and quiet skies. So Starlink is great for communications, and these nanosatellites are great for research, and they're very accessible and they're very easy to use. They're low cost, but at the same time, if they don't respect other space activities, then it's going to become a growing problem. Now, that is from both sides. I always tell astronomers like you have to be part of the conversation and you have to also see how you can collaborate with other technologies to come to this common interest, which is Earth protection, to be able to work together. It's not about that it's bad or not. So when it comes to nanosatellites, it's not a position of they're bad or not. They have things that can improve. For example, how we mitigate space debris and which technology we're applying to them so they comply with dark and quiet skies. And on the other hand, they're an excellent solution for developing nations, for universities and research. These tiny satellites are things that can be constructed by students. So they motivate them, and students are hands on what they're doing. And then they can put, for example, their experiments in there and take them as payload. And you can do a lot of research within the payload as well. So it's a whole process of designing it, and there's all engineers are working in that. So then you could have, for example, doctors and other kinds of scientists, like medical doctors or scientists, with their payloads inside, which is also very interesting. And then it's all the part of like propulsion and rock and the whole launching them, or if you're launching it with a launcher that it's already established, then you can see everything that happens in orbit. So they're fantastic for education. They're incredible for developing nations because it's very low cost. We just need to learn how to use these amazing instruments in a sustainable way, which is space debris and also dark and quiet skies.
Right. And when you say dark and quiet skies, I think you refer to, I have been reading a lot about astronomers based down here on Earth complaining about the Starlink satellites creating distractions in space. The measurements do go wrong. So I'm wondering, does that have an impact mainly on smaller telescopes that are looking up into space? Or does it also have an impact on something like the European Southern Observatory, where these uh, l- lines of satellites crossing the sky at different times creates a little bit of a distraction?
It affects everyone. Dark and Quiet Skies is a project that raises awareness about this need to preserve skies, on the one hand, dark. So when we are observing, or even with your naked eye, you can see the train of Starlink, or in our astronomical images, you can see sometimes these white lines, as you said, that are interfering with our observation. And that is something that affects everyone because, as we learned with the DART mission from NASA, that they sent, the DART mission was sent a satellite to go to one of this with Dynamos, which is an asteroid, to crush it and deorbit it. That was meant to be as planetary defense. And we used a very large telescope along with other observational telescopes to observe this and to help us with planetary protection, like the movie Don't Look Up. That is astronomy. So when other companies, satellite companies, have the bigger interest of Earth protection, they have to be very conscious as well that we are doing the same. So that's a common interest, and that's how we need to learn to work together, because they can't observe if we don't exist, like the dinosaurs, because the dinosaurs didn't have a space program, you know. But at the same time, they need to observe like backwards, which is what we can't do. Like ground-based astronomy cannot take a selfie. We only look to the outside. So we need each other, but we need to learn how to work with each other. And for the darkness is that sometimes in ESO or other institutes, organizations, there is so much research time. There's these people who are observing and they're writing their papers to further our knowledge, to further understand our universe. And that once they finally have their research, we come with the image, and the image is completely ruined by satellites. And that is not only a budget problem, but it's a time and work and dedication of someone there. You know, there's people behind it. So we need to learn how to work with this and the quiet part as well, because satellites they also use radio frequencies. So we need to learn a little bit to use this, and that is a problem. And it's a problem with satellites because they produce contamination, but we also have contamination here on Earth. I don't know if you knew, but 80% of the population suffers from light pollution, and a third of the population has never seen the Milky Way. That is so weird. It's like never been haven't been able to see the moon. It's just is there. Like the Milky Way is ours, is our heritage, is the thing that we share with with our past. Our ancestors looked at the sky, and even though it has changed, we still see some of the same objects and the same things. So we are made of stardust. That's why we have this natural and an unquestionable relationship with the universe, and it has a meaning, and you further understand once you see the night sky, and it's a right. And people they're deprived from it. It was taken away by them. So I understand that, of course, light is very important because we need to provide light and electricity to everyone in the world. I mean, we live of electricity, but at the same time, we need to learn again on how to work that and not take away that beautiful gift, that beautiful heritage, this natural resources that belongs to us as well, to the people. So it's a very fascinating project. This project raises this awareness, so people keep falling in love, and we understand our position in the universe. It's like an overview effect that astronauts have, but backwards.
Right.
So this is why it's so important. It's important for science. It's important for planetary protection. It's important for society, because this human culture, this heritage, we are part of it. We're part of the universe, and we've always been connected to that. We up to these days, there's people who love astrology, or there's people who still just like astrophotography. We are in so many ways connected to the skies, and it's always been something from ancient times that we've had it. So how can we take it away from people now or for the future generations? So the fact that one person, that a third of the population has never seen the Milky Way, it just is something that I wake up every day and it moves me, because I want people to see the skies that I've seen. The first time that I saw the real sky in Paranal, I literally cried because in that atmosphere where you have these stones and they were crackling and I could just hear that and see just darkness, and I couldn't, it was cold and I was not able to really see the sky because my eyes were getting used to the darkness. After 20 minutes, I've never seen such a beautiful thing in my life. And I literally cried because for the first time, I understood my place on Earth, how fragile we are, how small we are, and our place in the universe. And I finally understood that we are made of stardust. And it made so much sense to protect it. How are we not going to protect something that we're made of?
Mm, no, we definitely are made of stardust. And it's interesting you mentioned the movie Don't Look Up. I think that's one of the most underrated movies. Interestingly, you mentioned about the DART mission. Now, I think that is the first step to something that is going to be very, very important for all of us because, like we say, safety comes first, and we first have to protect ourselves before we can do anything else. And this DART mission, do you see it as something pioneering as well?
It is definitely pioneering. I think, and people sometimes can laugh that when I say the space. I mean, with dinosaurs didn't have a space program, and there's so many memes about that. But it's honestly true. We are like space. Of course, there's a lot of space between us and the objects, but we have natural protections. Like, for example, Jupiter helps us so much with absorbing, basically because of its gravitational pull. It just pulls all the objects to them because there's a lot of asteroids and meteorites going around. Thing is that Saturn, especially Jupiter is like the big protector from us. They help us to overcome this, and many times it's actually very hard to hit Earth, but the time that it hits, it's catastrophic. So we need to have a vision of the future, because what we're developing now is going to help us protect Earth, but it's also going to help us protect all the other planets and where we're going to go, because we are natural explorers. From the savannah, we just moved forward and conquered lands, and then we went into the sea and conquered the seas and went like from Europe to America, and then we conquered the skies. So and now we're conquering like space. And as I told you, like since the year 2000, we've never lived all together on Earth. So we are natural explorers. So when we have a moon base, when we go to Mars, when we become interplanetary species and we move into deep space, we will need this technology to defend other places that we're also going to call home. I am an earthling, and Earth is is always going to be one of my favorite like planets, because it hosts us. It's the best spaceship ever done, ever built, and we have to protect it. But once we move to Mars, there's going to be eventually Martians, people who are going to be born in Mars, and they're going to have the same feeling to their planet, and the same with the moonlings, and people maybe that later are going to be born in the moon, and the moon is going to be their home. So what we're doing now is not only to protect Earth, but it's also to protect us and whatever other celestial body we call dearly in the future. So it's definitely a vision, and it's just the beginning of something that I think is going to be incredible.
True. And like you said, the Earth is the mothership after all. We are all going to be. We are, in fact, already a spacefaring race now, and I think that's the future as we move there. But the background and the insight that you gave us into space law and issues, or your opinions on them, was very enlightening, AC. So I want to thank you for that, because there were a few things in my mind that I had to clarify as well. And talking about what we are doing right here on Earth, space law is one interesting part, and I did say that you had a lot of very interesting dimensions to what you do. But besides space law, if I just want to know a little bit about the European Space Observatory. And uh, in Chile, I guess there are three locations, and you can correct me if I'm wrong, because I think there are three. If you would just want to give us a little bit of insight into these three locations and sites and what goes on there.
Of course. So, the European Southern Observatory is an initiative of member states of Europe, plus the hosting country, which is Chile, because observatories are here, and a strategic partner, who is Australia. And altogether, this is the symbol of how collaboration can take us so far in space. And ISO actually this year was the 60th anniversary. So it was 60 years since ISO began. And ISO began with their first telescope here in La Silla, which is in the region of Coquimbo in Chile. And it was one of the most important sites because even though now it's a little bit more historic and it can be a little bit older, it is the base of everything. They developed some kinds of technology that would have never made possible to move further in other places in ground astronomy, as we have in Paranal, which is the other side, and what we're constructing now, which is the ELT, which is extremely large telescope that is going to completely revolutionize ground-based astronomy. So even though La Silla still is a little bit older, there's a lot of astronomy that can be done there. You can visit the sites. Actually, you can go every Saturday. It's open to public, and we have free public visits, so you can go visit it and see all the extraordinary things that La Silla has done and will continue to do. And that is like in that is like 500 kilometers, more or less a little bit more, from Santiago, which is the capital city of Chile. Oh yes. Then we have in Antofagasta, we have two of the telescopes that are working there. We have the VLT, which is a very large telescope, which is in Cerro Paranal. And Cerro Paranal is where it's on one side, and then you have Cerro Armazones, which is on the opposite side. And Cerro Armazones is where we're building the ELT, which is going to be the extremely large telescope.
Mhm.
And the VLT, the very large telescope, has four units which can work either separate, or and they have different instruments, or they can work together through interferometry. So they have the VLTI, which is a very large telescope interferometry, and they work as a massive telescope that otherwise we wouldn't be able to observe if they don't work together. And they have other auxiliaries, smaller telescopes. They look a little bit like R2D2 from Star Wars,
Yeah.
and those can move. So there, those are observations, and you can observe like these beautiful images that we have of galaxies and furthering everything we can see in the universe. And the very large telescope has done incredible discoveries, but what we're building now as an extremely large telescope is going to be revolutionary. We will be able to further understand dark matter, to see very close up exoplanets, and see if we figure out if there's life somewhere else and how to get there. We're going to open a whole new realms to understand like the first galaxies that were created at the very beginning of the universe. So the ELT is going to revolutionize like nothing has done before. It's going to be the biggest and the highest technology ground based telescope ever built. So in La Silla, we started with telescopes that were in diameter like 1.5 meter, 1.2 meters. Then we grew to a 2 meters telescope, then four, then eight, like in the very large telescope. The ELT is going to be 40 meters. It's a giant leap for everyone. So it's just going to be fascinating. And then there is another part which is called the ALMA telescope. And that is a collaboration where ISO is one of the partners. So, again, as I said before, the Atacama Large Millimeter Array, that is what ALMA means, observatory, is a radio telescope. And this radio telescope was begun as a collaboration between the United States, Japan as well, which are the partners, and also you have the ISO, and ISO in itself is another partnership. So there's so many countries involved in this collaboration. It's worldwide, truly, because we have ISO, then you have the U.S. National Science Foundation, and there's tons of and also from Japan that they're going to help with this. So it's absolutely with the National Astronomical Observatory of Japan as well, and so it's a massive collaboration. And I was recently there, and these radio telescopes are their antennas. They have so many of them. I saw they were clustered together now. I saw 54 of them clustered, that 25 were European, 25 were American, then four were Japanese. And the Japanese also have additional ones which are a little bit smaller that also work together. So you have about like 66 antennas. It
Wow.
was crazy to see them. And these antennas, they can work all together and they move as well, up to like 16 kilometers wide. And they observe, as a radio telescope, they observe more the cold parts of the universe. So things that they're on another in the spectrum, they're in another spectrum that the ones that the VLT does, and they are the ones that, together with other collaborations of radio telescopes in the world, they built the Event Horizon Telescope, which is a virtual telescope that is the size of Earth, quite literally.
Hmm.
And together they observed they had the first image of a black hole, and now they have an image of the black hole at the center of our galaxy, which is Sagittarius A. That is groundbreaking, and that is only international collaboration, because you literally, to observe this, you would need a telescope the size of Earth. We can't physically do that, but we did it virtually, and that is Alma. And for this last year, also in Cerro Chajnantor, where Alma is, you have Apex, and Apex is the Atacama Pathfinder experiment, which was one of the first, like, it was before Alma, and it's a single unit radio telescope as well, who also helped in all of this. And ESO is also part of the collaboration of Apex until the end of this year. So we have so many sites with so many exciting things happening.
Oh yeah, I think uh, you guys are really really lucky, and I do want to come back to the discoveries that's been made through these observatories as well a little bit later. But now to just so that I can also understand it and people listening to us, the building of these particular observatories and why is Chile so lucky? Is it the location, latitude, or is it the height? Is it orientation to the Milky Way or combination of all three?
I mean, it's due to its location. Chile, I mean, we have a unique location, and we have the north, because all of this is in the north part. So it's based in the Atacama Desert, which looks a little bit like Mars. Like,
Yep.
it's a very dry area, and we
I
have
also,
the one of the best
if I'm
worlds.
not mistaken,
Sorry.
it's a dry. If I'm not mistaken, I think it's the driest place on Earth. Uh,
Yes,
Actually, right?
it is. But this is like how, like, there is this juxtaposition of this dichotomy, because it's one of the driest places on Earth, but every now and then per year, the desert flourishes into these amazing pink flowers that they last very little and then they die. But we have a flower desert.
Mm.
Please look it up.
Oh yeah.
It's amazing. Atacama Flower Desert. It only happens in spring, the driest place on Earth. Boom, blossom of flowers, and then they disappear.
Wow.
But it is one of the driest places on Earth. And because there's what is called the Humboldt current, Chile has very weather that is very clear, and it allows astronomy to be able to take place. We hardly have any cloudy days, so you can't have clouds. And it's very dry, which allows, for example, radio telescopes cannot have humidity. That's why they are at 5,015 meters above sea level. That is basically halfway through to what a commercial airplane flies. And that's because at that point, at the 5 kilometers, the air density falls into half. Even though we are in space, it's 100 kilometers. At already 5 kilometers, we have half the amount of air. So that allows that it's less cloudy. So radio telescopes have a very dry environment. So there's no humidity affecting anything. And because of this current, and also in Paranal, we hardly have any cloudy days. So because they are optic telescopes, they can look into the night sky and have very clear skies and very dark. So it's an excellent place, but that's due to our location and our the natural phenomena that help our weather. And
Right.
of course light pollution, because it's very very far up in the mountains, like it's pretty far away and high.
Right, right. And you just spoke about some of the discoveries, and all of us have been fascinated with the first image of a black hole that we saw. And I think that is really stunning. There was, and I'm just wondering, that particular image, did it come from the Event Horizon telescope? And is that part of the telescopes in Chile, or is it part of a collaboration and that is located somewhere else?
Oh, it's a part of a collaboration. So the Events Horizon Telescope is a large telescope array that consists of a global network of radio telescopes. So, what this means is that to be able to observe a black hole, as I said, you would need a telescope the size of Earth. So, imagine trying to build, I mean, everyone knows the Death Star from Star Wars. Like that was pretty big. Imagine trying to build a telescope the size of Earth, like outside. Like it's basically, to our understanding and our development now, it's like basically impossible. So what they did is that the EHT project, which is the Event Horizon Telescope projects, combines the data from several very long baseline interferometry, so VLBI stations around Earth. So what this does is that you take the radio telescopes from different parts of the world, and Chile was included. Alma was part of this, and then you create like this massive virtual telescope, and with that you're able to, as you said, like to see the first image of a black hole, or also Sagittarius A star. So because it has an like a star, so it's Sagittarius A star at the center of our Milky Way. So that's how, but which is a lot smaller than the first one that we saw.
Yeah.
So together with this international collaboration, we're able to observe amazing and fascinating things like Sagittarius A star, which is the black hole in the center of our galaxy. But it's completely a virtual, high technology collaboration, which is, I mean, out literally out of this world.
No, definitely, because just the fact that we look at representations of black holes in most places, and you're always wondering, seeing is believing, and then finally when we did get a view of that, I think that was amazing with with that particular image. Now, the other interesting one that you guys were able to confirm was stars orbiting the Milky Way, or the black hole in the center of the Milky Way. I think that was another thing that took years to come to a conclusion, right? Maybe 30 35 years.
Yes, so in astronomy, well, first of all, astronomers are used to talking about like time spasms that are gigantic. So we are, I mean, if you work in social media or you work with that, I mean, TikTok has said that 90 seconds is already a lot.
Mm,
Here we're talking about millions of years and thousands of years. And I mean, astronomers honestly have a different time perception.
yeah.
So, for example, the extremely large telescope will be done at the end of the decade. That will be ready to hopefully have its first light at the end of the decade. And to me, at the end of the decade seems so far away. For astronomers, it's right around the corner. So when you say it took a lot of years, it depends who you ask,
Yeah.
because astronomers have a different like timeline, and observations take quite a while for me. So they're very long projects, and people are working for years and years on the constructions of the telescopes. Even also James Webb took quite a while, or Hubble telescopes. Like they all take a while, and the researches are also for quite some time. But in the astronomers' view, it was funny because we discussed this yesterday. They don't think it's that long, but because they have this other perspective of time.
And with the social media timelines, if you're not finding something out in 5 minutes or discovering another planet in 5 minutes, you're already too late.
Exactly, it already happened.
Yep. Yeah. The next cycle of images has already come through. With also, I think the first exoplanet was something that you all were able to capture, right?
Yes, exoplanets as well. And now we're doing a lot of discoveries because of we have a lot of advancements in technology to discover exoplanets, because there's different ways to discover exoplanets. But the extremely large telescope, the ELT, is going to revolutionize our understanding, observation, and findings of exoplanets. So I'm very excited to the ELT because it's just going to be out of this world, literally.
So, Isi, with you mentioned James Webb Telescope, and that must be very exciting for you as well, and astronomers and everybody involved in this science, with the images that have come back to us from there. According to you, what exactly excites you most about the James Webb Telescope?
The James Webb has given us so many wonderful gifts lately. Every time they release a picture or an image, I'm completely flabbergasted by it. I'm impressed. I think what excites me the most is that until now, because the ELT is still under construction, James Webb has given us pictures that reveals like things that we have never seen before with a level of detail that is extraordinary. So, for example, they revealed an exoplanet atmosphere as we had never seen before. They are showing us and giving us like such an insight into wonders that we wouldn't be able to see. Even if we had a super powerful telescope with our own eyes, it wouldn't be possible to see it. And with the James telescope, we are able to travel to travel distances that are inimaginable for us, and distances that allow us to see some things that are incredible and that gives us perspective on our place in the universe. I think that is what the James Webb's the most thing I'm most excited about. That besides their amazing images with a level of detail that is unprecedented, I think the fact that they are the James Webb is giving us a further understanding of our place in the universe, is giving us the gift of seeing where we are, the neighborhood of our galaxies, of where we are, and also teaches us the fragility of Earth and how special we are. Like you said, Earth is the mothership. So for me, the James Webb keeps every time they release his images keeps reminding me on how special we are. I mean, in this vast, vast universe, in the all the space objects that they observe, we are so special that we get to live in this wonderful mothership in this amazing Earth, and that we're able to build this technology and go explore to infinity and beyond. So that is the gift that the James Webb has given me. Besides the amazing images that are great for like screensavers and pictures to print as posters, what they're giving us is that daily reminder of our place in the universe and how blessed we are to have Earth as our mothership and why we have to protect it so much and hold it dear to our hearts.
Right. And just listening to you talking, you see, it is very obvious to me, and I'm sure a lot of our listeners, that you are very genuinely passionate about this particular subject, because we can hear it in your voice, we can hear it in the expressions that you have towards this that you're doing. And I also know, as a great communicator, you have been actively involved in promoting science, in promoting space, in promoting interest as far as these concepts are concerned to probably the younger generation. And when I say younger generation, you are the younger generation yourself, but probably to students that are still in school and not have not even got into college. So do you find that interesting as a communicator? I mean, I look at you as a communicator as well, besides everything else that you are doing. And do you see that as a mission, and is it important to you that you continue to spread this message?
Absolutely. I think that in many ways, when I wanted to go to the space world, they all told me like space. Chile doesn't have a space agency. Like space, you are a woman and you're not even in STEM. Like, what are you talking about? And as I told you, my journey has been very hard, lonely sometimes. And I think when you listen to other people or you have some reference or someone to look up to or to listen to that confirms that you are going in the right path is very important. I think communication is one of the most important like weapons that we have, because the passport to the future is education, but the weapons that you need to go through this is through communication and to find inspiration out there. So for me, it's part of my mission. When you say I work in the communications department in ISO and that I teach international law and space law at a university and that I'm a space lawyer, if you look at what I do, maybe doesn't make any sense. Like there's nothing gluing it. But if you fall deeper, you understand why I'm doing it. What is the passion behind it? Is that I want to make space accessible. So that's why I work in communications. So people can further understand and fall in love with space like I did. And be a teacher because I want to inspire the new generation to take a giant leap, bet for the things they do and do what they love. And if that is a space, Go full thrust in it. Don't look back. Just take your giant leap. And through the Space Generation Advisory Council, because I am from the young generation, then that allows me as a launching platform to further understand policies, to give a voice to all the young people, and to go further in the world. So when you put them together, you do understand that it all makes sense, because my why, my mission, is to democratize the access to space. And what makes my heart sing is when people hear me, or when they take their giant leap and they say, you know what, they write me sometimes on Instagram, in Easy Space, or in other places, and they just say, I listened to your podcast, or I saw this picture and I changed my life and I tried to do something different. I succeeded at it. And now they're working in the space sector because they're all shining stars. That makes my heart sing. So for me, communication, and it's everything, to be honest. And the more people we have in space, the more people that we have falling in love and doing what they love, it truly brings happiness to them and to me personally. So yes, communication is one of my favorite things, and something that I'll continue to do forever, because we need to inspire. And I didn't have that many reference, but that doesn't mean that the rest has to, because when you travel a lonely road, you have to pave it for the people who come behind you. And that's what I want to do. And for everyone out there, as I said, I was told so many times no, or that it was impossible. It's impossible until it's done. And yes, I'm not in STEM, so I have other skills, competences, and knowledge that other people don't have in the space industry. And I'm Latin American, and that means that I'm intercultural and international. And it's proven that teams that have diversity can further in so many ways, because I have another perspective. I lived other realities. I have other experiences that can add to this. And same because I'm a woman and I'm dyslexic, so I have other skills. And honestly, as Henry Ford said, that when everything seems to be going against you, remember the airplane takes off against the wind and not with it. So all of the negativity is just the wind under my wings. And if there's no space agency or space sector in Chile at the moment, well, Lincoln said the best way to predict the future is to create it. So you just have to go create it yourself. And if this piece of inspiration helps to do that, my heart will sing.
Brilliant. And you did mention Ford, you mentioned Lincoln. Have there been any other role models for you, or people that you've looked up to, or who have inspired you to take this on, maybe as scientists, communicators, people from present, past, and through their stories, you've seen them as inspiration?
I think that there is a lot of inspiring stories, but so the World Space Week had a challenge, and I was blessed to be one of the winners. And one of the challenges that you got mentoring sessions from an astronaut, Dr. Chris Boshausen. He's an astronaut. And this was recent. I just had my first session like 2 weeks ago. But the thing is, and I was discussing it with him, one has the idea, and the Apollo generation has the idea that it was these guys with the right stuff, like these amazing people who had like three PhDs, and they seemed unbeatable, and they seemed like Marvel, like they were superheroes, which you had to be, because you have to be very brave at things. But the reality is, and I was talking to Dr. Chris Boshausen, that it's not so much like that. There's a lot of astronauts that go through certain problems, that have some issues, and they fix it and they go on their way. So I feel like the Artemis mission is, and the Artemis generation, like we are going to show that space is a little bit more, it is way more accessible, and that space, it's a place that everyone belongs, and that we all have our stories, even if we have our ups and downs. So at the beginning for me, it was very hard to find someone as a reference in space, because they seemed unreachable. They seemed people that was not cut with the same scissors, as we say in Chile, it's a saying here. Like they were not me. And so for me at the beginning it was very hard, because they were only showing and communicating these superpower people and amazing people, and that was not me. Or people in NASA, and that's not me, because I'm not American, I'm not in the United States or in Europe. So it all seemed impossible. And I found many inspiration later, like now, with all the other people that I've been meeting. And but the two people that actually helped me launch my career in space and that have been incredible for me are actually not in the industry, and I've never met them, and they probably don't know that I even exist. But Simon Sinek wrote Starts with Why. Simon Sinek changed my life. That book made me be brave enough to quit my job as a corporate air lawyer and bet for space. Because I understood that it was not about what I was doing, but why I was doing it. And then I became unstoppable. And then I felt like that is what defines me. I'm not the Latin American space lawyer, I'm unstoppable because once I have my dream and my target, I'm going to put a strategy and go there. I want to go to space. I want to be an astronaut. I'm going to do everything possible for that to happen. So, Simon Sinek has changed my life. And then the other person that also changed my life also doesn't know me, also has no idea that I exist, and that is Darren Hardy. And Darren Hardy wrote The Compound Effect. So I got Simon Sinek to further understand my purpose and how to deploy that purpose and how to execute all of these ideas. I did it thanks to Darren Hardy because his book is brilliant and he has so much free material that you can access that is written, that is audio. Darren does amazingly in this, and he changed my life as well because as I started to follow his advice and follow what he does in a certain way, I changed myself completely. I became another person, what James Clear, like the author of Atomic Habits, would consider like at an atomic level. My inner self started to flourish, and I started to become the person I have to be to make it, because it's not faking it until you make it. First, don't fake it. That faking is so hard, and it's not about making it. It's about becoming the person you have to be to fulfill your dreams and accomplish your goals. And that's to stay true to yourself and work on yourself. So Simon Sinek and Darren Hardy completely changed my life.
Inspiring. And it's interesting you mentioned Simon Sinek because there's a quote that one of his quotes that is also something that is one of my favorites. What Simon said, Sinek says is there are only two ways to influence human behavior. You can manipulate it or you can inspire it. And I think that particular quote summarizes everything and everyone you meet and see around. It's either somebody who is manipulating your behavior or somebody who is inspiring your behavior. It's as simple as that. So, what can somebody do if you said you are not from STEM? I'm not from STEM, for example, and they still want to be involved. They still want to contribute. They still want to probably at this stage or age stand up and go back to studying and doing something new. Now, two things. One is, where do people find you? First of all, is are you available online? And if somebody does want to follow you or your work, where do they do that? And the second part of the question is, what can somebody do? But would you like to give them some advice?
Of course. So, as I said before, some of the lessons that I learned is that first from Henry Ford, when everything seems to be going against you, remember the airplane takes off against the wind and not with it. So the first step would be try to read Start with Why by Simon Sinek and find your why, find your passion, find what makes your heart sing. And then you figure out how to do it and eventually what to do. So thinking about what to do in space is the wrong approach. First start with why, how, and then the what. And the one that's going to fall into your like on your face, trust me. And it's never too late to begin. So even if you feel like you're starting very late, that's not true. And because when you're doing the things that you love, trust me, you're going to be so happy, and you're going to become unstoppable because no one will be able to, it's not compete, but no one will be able to match you if you're doing the things that you're so passionate about. So find your passion and find your arena. Because if I say that a competition is to climb a tree, like the monkey's going to do great, the fish is going to do horrible. But like you have to just grab the fish and the monkey, for example, and you throw them at the sea, and the fish is going to excel. So you also need to find your arena. With a growth mindset, you can do anything, but you can't do everything. So focus in what you like and focus in what you're passionate about. If you're bad at math, well, Einstein was also bad at math in school. And if you think that I am speaking in English right now, which is my second language, and I'm a space lawyer, I'm terribly dyslexic. I mean, I had literally no future if I would have followed the advice of people back then that I had no future anyways. Because someone else's opinion is not your reality. So you have so much power in you to decide to do whatever you want because you're a product of your decisions and not your circumstances. Circumstances are that I was not meant to make it in the space sector for all the things that I already mentioned, but I am because I decided to do so because you have the power to change it in yourself. So create your own future if you want to predict it and use everything against you as the wind under your wings and just don't listen to haters because they're going to be haters everywhere and they're going to try to stop you, but someone else's opinion is not your reality and you can decide to forge your own destiny. So that is what you have to do right now. So if you have to start jumping out of your chair, start reading the books that are going to get you there. And Simon Sinek and Darren Hardy are great places to start to begin this journey because it is a journey and a journey has ups and downs. When you're in an airplane, sometimes you have food and you watch movies, sometimes you have turbulence. I mean, it goes in ups and downs and you have to enjoy every single part of it because everything that is a struggle is just making you stronger and preparing you for the greatest challenge you'll have in your life. So, and regarding if you think, oh, but that person was lucky, luck is just when opportunity meets preparedness, you have the right mindset and you can action upon it. So, if you want to be quote unquote lucky, start preparing now. So when the opportunity comes, you can grab it and always visualize it and have the right mindset to do that. The mindset of yes, we can, the mindset that it is possible, and it is always impossible until it's done. So I think in very general terms, that would be my advice. And find your arena, find the greatness in you because everyone has greatness, and start developing and start now. Because honestly, once you start your journey, you'll never look back and your heart is going to sing every day.
A lot of people listening to this particular episode, Isi, I'm sure are inspired not only by your story, but also by the field that you are in and the the way you described your journey. Isi, from everybody here in India, people listening to us on Indian Genes, and you do know that uh, we've got about 65 countries where Indian Genes is being heard. And I have an interesting question for you, Isi, before we let you go.
Of course, please.
So, the question is, do you know the only podcast on Mars? Or is there a podcast on Mars and the only podcast in the world that is on Mars today?
No, I don't know. There's a podcast in Mars.
Okay, yeah, that's Indian Genes.
Oh my God, that's amazing.
So,
Congratulations.
yeah, and I have proof for that. So what we did was 3 years ago, if you remember, Perseverance was going into Mars,
Yes,
and they had this application form where you could fill in your name and you would get a ticket, and then your name
yes,
was going to be inscribed on the rover once it goes to Mars. So I had put in Indian Genes podcast and I'd sent it to them, and they gave me a ticket and a registration code and everything back because I know people are sending names to Mars. So besides all the names that are today on Mars, uh, if there is a Martian that picks up those names, the first podcast that they'll see is going to be Indian Genes.
that's amazing. And I love the vision. This is truly like, I love the way you think. I love how you think out of the box. This is great. I love it.
Till NASA let somebody else send their name there. But
Amazing. Well, you'll always be the first. This is
yeah, yeah,
truly, literally out of this world. I love it.
yeah. And once again, Isi, thank you so much for spending time with us. And hopefully, we can get you back here if you ever want to come back to speak to us.
Of course, I'll be more than happy to. And if anyone wants to reach out, I'm very active in Instagram, especially. You can find me at Isi Space, which is ISI, lower line space. And if you can put it in the description, that would be awesome. And then write me. I have so many people that write me. I'm so happy to always talk to everyone. And honestly, anything anyone wants to talk about or tell me their story, I'll be more than happy to hear it, because we have to support each other. It's about collaboration. So honestly, thank you, Joaquin, so much for inviting me here and to let me tell a little bit of my story.
Thanks a lot, Isi.
इस हब हॉपर ओरिजिनल को सुनने के लिए आपका शुक्रिया। अगर आप भी अपना पॉडकास्ट लॉन्च करना चाहते हैं तो हब हॉपर स्टूडियो वेबसाइट पे रजिस्टर करें और 1 मिनट के अंदर अंदर अपना खुद का पॉडकास्ट लॉन्च करें। यही नहीं, स्टूडियो देता है आपको पूरी आजादी कहीं भी कभी भी अपना पॉडकास्ट लॉन्च करने की, सिर्फ 3 आसान स्टेप्स में। तो साथ में अपना पॉडकास्ट शुरू करने के लिए तैयार? जस्ट हॉप ऑन हब हॉपर, सिंपली कंटेंट।